All right, as we get started, go and take your homework out. Turn to page 47 in your textbooks. I want to review what we talked about yesterday, what your homework was over. That was multiplying fractions. And I said that to multiply fractions, do we need a common denominator class?
Yes. No.
She answered with great confidence. That's plausible. But to multiply fractions, no, we don't have to have a common denominator, which is wonderful because I'm lazy. And common denominators take work. Which is why I don't like adding fractions, because we have to have that least common denominator. But to multiply, no common denominator needed. In fact, really, multiplying fractions is a lot like reducing fractions, where we just cancel a bunch of stuff, right? Or at least we cancel class factors. We never cancel terms. So if we had a problem like this, there are some factors I can cancel, but there are some things that aren't actually factors, right? The 9b is a term. The negative 12bc is a term. And as long as you have terms, you can't cancel anything with that. So I said, anytime you see a polynomial, do one of two things, Kendall.
You can group or factor.
Group or factor. What would I do here?
Factor.
What would I factor?
A 3b.
3b, and that would leave us with?
3b.
Wait, I thought I pulled the b out.
3 negative 4c.
There we go, 3 negative 4c. And once everything's been factored, now we get to cancel some stuff. Maddie? I'm sorry? The 3 and 6 to get. All right, Michael?
You can cancel the 4x and then the 10x.
Okay, and cancel, well, let's just take the 4 and the 10. What cancels out of 4 and 10?
2.
A 2 to get?
2 and 5.
All right, Genesis?
The x is one of the x's.
All right, this x with one of these x's, so I still have in the denominator. By the way, the x didn't disappear from the denominator. You see that it's gone from the numerator, but it's not gone from the denominator, so I don't have to say it can't be 0. It wouldn't be wrong to say it, I just don't have to say it. Abby?
The a's.
All right, this a with one of these, so I still have
A.
in the top. There we go. This a did cancel. So when I get to my answer, I need to specify that that a class cannot be 0, just like we would with reducing fractions. Okay, Brandon?
The 2's.
Yeah, the 2's, straight up and down cancel. It's still numerator, denominator, right? Anything else? Let's do it again. Audrey, anything else, or are we pretty much done?
You can cancel the b's.
Oh, the b's will cancel with each other. Now, these are the only b's in the entire problem. There are no b's anywhere else. So if I don't say b can't be 0, technically I would argue that's no big deal. Some would say, no, anything that cancels half out of the denominator, gotta say can't be 0. Whatever, okay, so we'll say it to keep those people happy, but I wouldn't take points off on a quiz if that one didn't get included because our answer isn't gonna have a b in it at all. What is our answer gonna be? Back to Kendall now.
A times 1 3 minus 5c. Over 5x squared.
All right. And what seems to be the problem here? We're having a pencil pouch malfunction?
Eraser.
Eraser. Okay. All right. Questions on this? Questions on this? All right. How about this one? Write this down on your paper if you would, maybe underneath the homework. A cubed plus a squared b plus ab squared all over a squared minus b squared. Multiplying that by a squared positive ab over a cubed negative b cubed. Now let's talk through this multiplication problem. Again, technically you could just multiply straight across the top, multiply straight across the bottom, and try to reduce, good luck at the end. But a much better way is to do your reducing by canceling any numerator class with any denominator. Good. Numerator can cancel with denominator. Denominator can cancel with numerator, right? But we only cancel factors. We never cancel terms. And for that reason, if we see polynomials class, we must either factor ideally or group if something doesn't factor. Looking at this, let's start on the other side here with Brandon.
You have to turn it into and use factors for.
Well, if I had what we call quadratic, right, where it's squared first, gone first, squared possibly, right? But it's not quite quadratic. It doesn't start with squared. But maybe I could do the first thing I should always check for when I factor. A, very good. You can factor out A, and I was waiting for you to say something, but you were meaning you can factor out A. Very good. And when you pull out the A, what am I left with?
A squared plus AB plus B squared.
All right. And now do you see this is more quadratic, right? Squared first, gone first, squared. That's quadratic. That might be something, class, we could try to backwards FOIL. Think about this, though. If I backwards FOIL, the A squared class has to split into A and A, right? And the signs have to be positives, right, because of the middle sign. And the B squared has to split into B and B. This is literally the only way to factor it. But the iterator doesn't check, does it? What would the iterator have to be there, class?
2AB.
2AB, right? AB, AB, 2AB. So what that means is it won't actually factor anymore. So we'll leave it just like that. But it doesn't hurt to give it a try, right? Looking at the A squared minus B squared. Let's go to Abby.
Difference of squares.
Let's factor into.
Conjugates.
And we get.
A plus B times A minus B.
You like that big fancy word, don't you?
That's
Some
what
and
I
dip.
said all last year.
It's okay. And the A squared plus, it's not wrong. It just sounds cool. The A squared plus AB, Genesis. All right. Could have said common monomial factor. That would have sounded cool too. All right, what are we left with? A plus B. What about the A cubed minus B cubed? Michael?
It can go into a monomial times a trinomial.
Well, binomial times trinomial, right? So it's just some difference of cubes here. What's the binomial going to be?
A minus B
And then the trinomial.
is A squared plus AB plus B squared.
And suddenly I don't feel so bad about not being able to factor this class, considering now I can cancel it. Now, trying to set that unequal to 0, you can't really get a letter by itself anyway, so in our answer, we'll just say that A squared plus AB plus B squared can't be 0. Because you can't isolate any one letter in that instance. What else might we do here, Maddie? I'm sorry? Like, well, not terms. We don't cancel terms. Factors. Yeah, we cancel factors. What factors? Okay, the A plus B's cancel. So I could say that A cannot equal negative B. All right. What else cancels here, Audrey? Nothing. It's tempting to cancel those A minus B's, isn't it? But they're both denominators. Tempting to cancel those A's, isn't it? But numerators. So what's my answer going to be, Audrey?
A squared over A minus B squared.
Good, and I like that she said A minus B squared as opposed to A minus B because I'm lazy and don't want to write it twice. I'd rather just write it to exponent. And there's our answer there. Questions on this multiplication of fractions. All right. How many pretty sure that's what I did in my homework last night. I think I did it right. Feel pretty good about homework. All right, let's take a look. Page 47 in your textbooks. And number 20 was our first problem here. Monomials, right? So that means everything technically is already factors within these individual terms, so we don't have to factor anything. What did you get for your answer here, Brandon?
I know. 1 over 2 B squared YZ.
There's one little thing that you missed that's in the numerator. By the way, I like, though, since he thought everything canceled out of the numerator, that he left the 1. However, there is one thing that was still in the numerator that didn't cancel away that your eye missed. Genesis? M to the 12th, right? That M to the 12th never had anything to cancel with. So it should have been M to the 12th over the 2 B squared, P squared, YZ. One qualifying statement that the book would make, I don't think you have to make it, and that's that A can't be 0. But if you look at your answer, what A, right? But the book does have that qualifying statement there. I would contend you don't need that statement. How many did have the M to the 12th over 2 B squared, P squared, YZ? All right, just missed M into a little. And again, everything else, you cancel stuff and it's written up higher, and the M to the 12th is back on ground level, as it were, so it's easy to miss. I did it myself a couple weeks ago, you might remember, so easy to miss those. Number 22. This time we're going to do a bunch of factoring and stuff, and what did you get this time, Michael?
X negative 5 over X negative 4.
Good, and we do have 2 qualifying statements here.
I didn't write those.
Okay, anyone got the qualifying statements to go with them? Abby?
X cannot equal 7/2 and -4.
Good. X can't be 7/2, nor can X be -4, based on those two things that canceled away. But the main answer is correct. X -5 over X -4. Take a look at number 23. And what do we get for our answer here, Maddie?
-13 over squared plus 5 plus 25 cannot equal 2 over 5.
You're sure you're not doing that on purpose? Like it feels like you slowed down before you do it for dramatic effect. That is correct. N minus 13 over N squared plus 5N plus 25, where N can't be 2 or 5 is correct. Great job, Maddie. Number 25. Number 25, what did you get, Kendall? Ooh, lots of factoring here.
Y plus 7 times the quantity y minus 2 over the quantity y minus 5 times the quantity y plus 8.
Good. A lot of stuff that didn't cancel. Lots of factoring, not as much canceling as we're used to seeing. So good. A couple qualifying statements.
Y cannot equal 0, -2, and -8.
I've got the y can't be 0. You should have canceled away a y minus 2. So we could say y can't be
2,
positive 2. And then what was the other one you said?
-8.
Okay. Because you canceled away a y plus 8, correct?
Mm-hmm.
But look in your answer. Do you see there's still a y plus 8 in your denominator? So do we have to say y can't be -8? We don't have to. But is it wrong to? No. So when in doubt, throw it in there. That we don't risk missing something you should get. But technically, y positive 7, y negative 2 over y positive 8, y negative 5. You at least have to say y can't be 0 or 2. And you could, I suppose, have y can't be -8, though that's not necessary. Number 26. Again, tons of factoring to do on this problem. And Audrey?
1.
And unfortunately, lots of canceling. Right now, again, my argument would be if the answer is 1, there are no qualifying statements left. But technically, the book would argue, I think erroneously, that we have several statements of things that A could not equal, at least in the original problem. Did you happen to write those? What'd you get?
-2, -8, -1, 0, -5.
Got all of them right. 0 can't be, or A can't be 0, -1, -2, -5, or -8. But again, I would contend, what A is it that can't be these things? There's no A's left. But 1, your answer. Did anyone go 5 for 5 on this page? Okay, a couple of you did 4 for 5. Just missed 1. Right, 3 for 5, just a couple problems. Are there any questions? I know we talked through most of it. We didn't actually work it on the board. Are there any say, could we please see it worked before we move on? Any questions? Going once on questions. Gavin has a question, but I can't hear it. Someone else here, Gavin? See which one he wants to see worked? Sorry, Gavin, have one me only. All right, let's take a look at page 56 now. Turn over to page 56. And let's take a look at 17 and 18. And since we didn't work any of those out, I'll go and work both of these out the quick way. Meaning, try to do the initial step in my head, or in our head. Number 7, our heads. Anyway, number 17. The first fraction, nothing's going to factor, right? So in number 17, class, we should simply group the x plus 8 and the x plus 12. And again, I know technically the fraction bar groups, but the advantage of putting parentheses is you're not tempted to look at this 8 and see, ooh, I can take a 4 out. No, you can't. It's not an 8. It's an x plus 8. Oh, I can cancel the x. No. It's an x plus 8. You can't cancel anything but an entire x plus 8. Then we come to the second fraction. What does that numerator factor into? Brandon?
Quantity x plus 12 times quantity x minus 5.
Excellent. And then what does the denominator factor into? Audrey?
X plus 2 times x plus 8.
Good. Initially, by the way, it looks like a PST, doesn't it, down there, right? Perfect square, positive, even. But if you did the x plus 4 quantity squared, that multiplying double would come out to an 8x. And we needed the 10x. So backwards FOIL. From here, we cancel away, Abby, the...
X plus 12.
And?
X plus 8.
So our answer?
X -5 over x plus 2.
Where?
X cannot equal -12 and -8.
And there's our answer. How many have this just exactly like this for number 17? Perfect. Number 18, same thing again. Group the x plus 5. Group the x -9. Backwards FOIL Genesis, the numerator into
X minus 9, X minus 11.
good x negative 9, x negative 11, and the denominator, Michael, into
X positive 5, X negative 8.
good, and then Maddie, to get where x cannot equal, and there's our answer. How many had this answer just like this for number 18? All right, do we feel like we're good with the multiplication of fractions? We're like, we can move on already, we got this. Feel good? Anyone say, we please practice another one, I'm scared? Anyone scared? Nobody's scared. Brecken's scared. All right, have mom email me. All right, next section of your notes then, we move on. And division of fractions. Next section of your notes, dividing fractions. Dividing fractions. You should recall, if you go back to your not even junior high days, your elementary days, that the first time you saw this, like something like a 2/3 divided by 4/7, your teacher told you you never actually divide fractions. Your teacher told you instead that anytime we see a division problem, we're going to change it to a multiplication problem. And we're going to take the fraction after the division sign. Notice I didn't say the second fraction. That's what if you had a more complicated problem. But whatever comes after the division sign, class, what would you do with that fraction? Flip it, right? And you change this to a multiplication problem. 2/3 times 7/4, right? That's what you did in, I think it was been 3rd or 4th grade when you first learned this. And things haven't changed at all. With algebra, now that it's a multiplication problem, we cancel like we would have before to get 1 and 2, and we would end up multiplying straight across to get 7, 6. And if we were in elementary school, we would have had to change that to a mixed number class. 1 and 1, 6, then we'd be all happy and whatnot. Okay, here's what I need you to write down in your notes. Multiply by the reciprocal. Multiply by the reciprocal. You didn't learn that word in 4th grade because that's a big hard word for little 3rd or 4th graders, reciprocal. But reciprocal means flip it, right? We're familiar with that already. We're just going to flip the one after the division symbol. Even if, let's just make up a weird problem. You had something like A over B times C over D divided by E over F divided by G over Z equals. All right? And in a problem like this, well, anything that comes after division sign gets flipped. So I would rewrite this, Audrey, how?
You would write A over B times C.
Well, we use a raised dot now, I guess.
Yeah, times C over D times F over E times Z over G.
There we go. And since nothing cancels, we just multiply straight across and we get ACFZ over BDEG, and there would be our answer, right? Okay? Anytime it comes after division sign, it gets flipped. If it's not after division sign, it doesn't get flipped. Pretty easy? So, I just said, does anyone want to practice more multiplication of fractions? You're going to do it anyway. Because that's what we're still doing. We just have to flip something first. Look at page 44 in your textbooks. Same song, second verse, a little bit harder. Hopefully no worse. All right, page 44, look at the example problem there. And notice, I'm just going to kind of talk through this with you. We've got an a over a plus 4 divided by a cubed over a squared minus 16. I would never copy a division problem onto your own paper. What a waste of time, right? Instead, write it down as the a over a plus 4 times the reciprocal. And in fact, I would factor, instead of writing a squared minus 16 over a cubed, class, I'd factor the a squared minus 16 that moves up into conjugates, right? A plus 4, a minus 4. And then, of course, the a cubed, it doesn't factor at all. So this is how I would copy the problem onto my own paper. Does that make sense? Just too lazy to write the problem down and then write it down flipped and then factor it. Go straight to this, right? I think all of us are good enough to be able to do that. And then we cancel some stuff, class.
A plus 4.
A plus 4 is, then we cancel a and a cubed to get a squared. So our answer is this a minus 4 over a squared, right? Or since we canceled the a plus 4.
A cannot equal
A can't equal -4. And notice the A itself didn't cancel out of the denominator, right? So we don't have to say A can't be 0, but there's one more thing that makes division a little bit harder. And it's this. This A minus 4 factor used to be in the denominator, didn't it? It didn't cancel out of the denominator. It flipped out of the denominator, didn't it? It reciprocated out of the denominator. But the point is, it used to be in the denominator, and it ain't there no mo'. So anytime something ain't in there no mo', we have to set it unequal to 0. So even though this guy did not actually cancel, because it used to be a denominator, we have to specify A also can't be +4. Does that make sense? That's the one other difference with division. The flipping is not the hard part. We can all flip a fraction, no problem. The hard part's going to be paying attention to a factor that doesn't even cancel, but it used to be in that denominator. Does that make sense? One thing to watch for. Write that in your notes. Any original denominator must be set unequal to 0. When I say original denominator, meaning it ain't in the denominator no more. Okay, so any original denominator that moves to the numerator, I guess we could say, must be set unequal to 0, even if it doesn't actually cancel in the conventional sense. Questions on that? Any questions on that? Let's look at the next example. Look at the next example. We've got this x plus 3 over x minus 4, and it says divided by x plus 6, x plus 9 over x minus 2, x minus 8. We don't divide fractions, class. We... Thank you, Audrey. Okay, all of us, let's try to get it together here. We never divide fractions, class. We multiply by the reciprocal. So we see fractions and we see division sign. We're like, ain't gonna do it. Class, we're going to... Still a little weak, but whatever. All right, so we're going to keep the first fraction, because anything comes after division. So I'm going to keep the x plus 3 over x minus 4, right? I'll even group it. And then I'm going to change it to times. We're going to flip. So the x squared minus 2x minus 8 goes up. X squared minus 2x minus 8. Can we backwards scroll that in our head? X squared splits into x and x. The sign's in negatives. That tells me, how should I split up the 8 to wind up with a -2?
-4 positive 2.
-4 positive 2, right? And then the x squared plus 6x minus plus 9 moves down. Let's do the same thing with it, factored into x and x, positive. 3 and 3 gives me the 9 when you multiply 6x when you add. There we go. Okay, so again, I would start with that step. And then from here we get to cancel stuff. What stuff is going to cancel here, Michael?
The x plus 3. And then the x minus 4.
All right.
Pretty good.
Very good. So our answer?
X plus 2 over x plus 3.
All right, now it's time for excluded values. X minus 4 canceled from the denominator. So class? X can't equal 4. X plus 3 is actually still here, isn't it? One of them canceled, but I still have another, so I don't have to say it. But if you're like, oh no, I just get confused, just write it then. X also can't be class -3. It would not be a problem to write no points off if you write that. But there's one more thing that didn't cancel, but it's not in the denominator like it used to be, class. X plus 2. So in the second fraction, if you will, the one after where the division sign used to be, if it's still sitting up there, remember that used to be part of a denominator. So it used to be true that x couldn't be -2. Now it looks like it can be, so we'll also specify x can't be -2. Does that make sense? Questions on the second example? Do we understand the examples here on page 44? All right, turn in your textbooks now to page 48. Page 48. And numero 30. Do not copy it the way it's written in your book. Copy it down as multiplication by the reciprocal on your own paper. Number 30. Top of page 48. Obviously no factoring needed here, right? Monomials, so we're good there. And Maddie is going to tell us how she wrote this down. On number 30.
Yeah. G to the 8, H to the 13 over W squared logic 4 times W to the 4th logic 7 over H squared logic 20.
And what compelled them to go out of alphabetical order right here, I don't know, but my OCD feels a little triggered. Anyone with me? I was looking for reaction earlier on the A is to B, E is to F, and all that, and I was looking at Audrey for a reaction. I must have made you callous after geometry last year, because I got no reaction on G over Z. Like, I was like, no. I was slightly disappointed there, Audrey. All right, so so we flip it, and we just cancel stuff. What stuff are we canceling here, Brandon? G's to get in the bottom. By the way, G's not gone from the denominator. We don't need an excluded value there. Hey, and because we're canceling, that takes care of the alpha order anyway, right? But we didn't take an H out, right? So later on, we'll need to say class H can't be 0. What else? So, there's something else that came out of the denominator class. Well, just W can't be 0, right? W squared can't be 0. When you take the square root of both sides, W can't be 0. So the letter individually. Keep going. The Y's to get Y cubed. There's another excluded value. Y can't be 0. And so what's the answer going to be here, Brandon?
H to the 11, W squared, Y cubed over G to the square.
There we go. How many of the same thing Brandon had? The same thing Brandon had. Any questions? Number 34. I dropped down to number 34. And take just a minute. I want you to copy it down the way I would copy it down. Take a moment. Not as a division problem, but as multiplication by the reciprocal, but factored. 34 at your seats. Factor as you copy. I think we can do this. I want to push you to do this. Let's see how we handle it. Look up this way once you've got it just copied down the way I would. Instead of going ahead and working it, though it'll take like 2 seconds to work it after. I just want to see where we're at as far as getting it copied down. I'll make sure we're able to handle this. All right, Genesis, let's go to you. How did you write the problem down?
Y minus 9 y plus 1 times y plus 4 times 1 minus 10 over y minus 9 y plus 12.
Perfect. And I'll go ahead and group these as well, just, for sake of seeing it. How many copied it the way Genesis did? Did all the factoring, everything perfect? Any questions at all on this? Now the easy part, Genesis.
Cancel y minus 9, y plus 4.
All right, our answer?
Y minus 10 over y plus 12. Y will equal positive 9. And negative 4.
And one more, anyone?
12.
Positive 10.
Positive 10. Used to be a denominator, now a numerator. And there we go. Questions on this? Ready to try some completely on your own now? All right, I want you to do numbers. Let's do 32 and 33. 32 and 33 seats. Makes you feel better? Hang in there, we're almost done with fractions. Okay, class. Teacher error. I was just checking my answers. What did I do wrong? I screwed it up. Not completely, but there's one mistake that I made that's critical. The n. I have an n to the 6th down here, n to the 36th up here. How many n's am I allowed to cancel? 6. If I take 6 n's out, they're all gone. If I take 6 n's out, how many n's should have been left? 30. Because when we divide, that's what a fraction bar means, we subtract the exponents. I'll own that one. All right, so good job. How many else caught n to the 30th there? Several of you. Good. Pretty much everybody but me. Outstanding. Make sure that doesn't happen again. I started copying the wrong problem on this one. It's 33. Not sure what I was writing. That is 33. Now I'm like, I need more sleep at night. I was copying the right one. Brandon's good. Abby's good. If you finish early and you're good, go on to 36. We're going to take a look at that together here in just a minute. I'm going to give you a chance, if you're done early, to take a stab at it. Take about 30 seconds longer to finish up these two before we take a look at 36. And once you finish, check your answers, which are finally correct. All right, pencils down, even if you're not finished. Any questions 32? You should have had questions if I'd left it up there that way, but when I looked at the answer key, I realized my answer was wrong and went ahead and addressed it early. Questions on 32. How about 33? How many got it correct before you checked the board? You were perfect before you looked at the board. All right, any questions on 32 or 33? Feel like division of fractions not, messing us up at all? We're good, we got this. All right, go ahead and put 36 down. Or at least sort of copies down. Let's take a look at this one together. One weird little twist. Anyone see as you're looking at 36, what about 36 makes it just a little obnoxious?
It's a negative.
That first term, negative, right? And would a flip-flop be appropriate in either case on 36? I would say no. Here's why. It's G then number, G then number, G then number, G descending down to a number, right? If you flip-flop that first denominator, right, 8 minus G, you just switched it backwards of everything else. So really in both cases, class, we're going to want to do what? Factor out that negative. So my first fraction, of course, G minus 3, I'm going to leave. I'm going to factor out the negative. Where does the negative have to go, class?
In the front.
In the front. And then what's left in the parentheses down here, anyone?
G negative 8.
G negative 8. Good. All right, now, because of the negative, class, I'm going to break my rule. I am going to copy down a little bit here on the multiplication because I don't want to try to do too many steps in my head and screw up. Does that make sense? I'm lazy, but I hate getting wrong answers, okay, especially after the end of the 30th. So I'm going to take the precaution. I'll move the G to the 4th minus 81 down for now. And in the numerator, class, as I copy it, let's factor out that negative. Let me give myself a little room. I'm going to factor out the negative, put the negative where? In the front of that fraction. So notice we have two negatives being multiplied here. Our answer, class, is going to become a positive, right? Negative times negative will end up giving us a positive answer here in a minute. But then in the numerator now, what do I copy with the negative factored out? Genesis?
G to the 4th plus.
Well, the G to the 4th minus 81 we moved down. It's the denominator that we're now moving up that we're pulling the negative out of. So
G squared minus 6G minus 16.
There we go. So again, I want to go ahead and get that negative out first. Then let's go ahead and finish the backwards FOIL here. Let's go to Kendall.
You have G and G. Positive and negative. 8 and 2.
There we go. Where we want, which one to be which? We're shooting for a negative 6, so let's make the
8 and negative.
And then the 2 the positive. All right. And then obviously the G to the 4th minus 81 class factors into conjugates.
G squared negative plus 9.
G squared plus 9. And then this would be
Conjugates.
the other part, right? G squared minus 9. But that's another difference of squares. So instead of writing, again, this is Algebra 2 level here, right? Instead of writing G squared minus 9, let's write
G plus 3.
Now, if you can, now again, if you need to write both, again, you do what's best for you. It's pointing out there's some little things here that we can maybe do because, lazy. So now what? Now that we've flipped everything, we see the two negatives. We already addressed those. It's going to multiply to give us the positive. What else can we do here? Maddie? Negative 8? Anything else? All right, so how do we write the answer now, Maddie? Good, even got the last one there. G cannot be positive 3, positive 8, or negative 2. Some of you got a head start on this one. Were we on the right track? Those who had the head start, were we on the right track? Okay, any questions on what to do with these weird negative stuff? By the way, both of them happen to have a negative that factored out. What if only one of these had a negative to factor out? Figure it should be negative at the front instead of positive, right? No big deal there. Questions on pulling out negatives. Page 56. Page 56. Two more as we close out the hour. Two more problems for you. And they are numbers 19 and 20. 19 and 20 on page 56. 19 and 20, they're on page 56. By the way, don't get in the habit of always flipping. Remember, the whole reason we're flipping these is because they're division problems. Sometimes I've seen students on quizzes or tests flip a multiplication problem. Oh, no, stop! Only division gets flipped, okay? Multiplication, you leave it alone, but just a word of caution since it can be tempting. Now that 84 is nasty, right? Could you go on that page soon? Quick strategy tip for you, okay? I was standing there looking at the 84, and my first thought is 7 times 12, right? I mean, 96, 8 times 12, 84, 7 times 12, but I realized 7 and 12 are not giving you an 8. I'm like, well, 4 and 21, I can see that pretty well. 4 and 21 aren't going to give me an 8. It's like, Well, you could get out the calculator, right? And you could try 1 times, we already know that without the calculator, 2 times 42, 3 times, that I would like the calculator for, 26, something like that, 28, 28. That's not giving me 4 times 21, I can do that without. 5 definitely does not go in. 6 times 14, calculator helps there. That could give me an 8 if I make the 6 the negative and the 14 the positive. But you know, there was a clue. This r negative 6 won't necessarily, you listening? Won't necessarily cancel with anything. but it might. And after I saw the 6 and 14, as I'm thinking through these mentally, I'm like, oh, duh, the 6 should include me, and I'd want 6 and something. Then he did the calculator out, 84 divided by 6. Hey, it works evenly. There's my 6 and 14. Maybe even here on the 96, if he didn't think of 8 and 12 right away. Here's an 8. Maybe there's an 8 in one of these, right? So again, some little ways you can kind of cheat the system. Look at the other fraction to help you figure out what numbers you might want to use if the backwards FOIL's hard. And then, of course, the canceling is the easy part. And I'm getting r plus 12 over r positive 14. Make sure I do copy that right, yeah. And r cannot be class 6 or negative 8 or negative 12. And some of you finished early. Did we have this answer? All right, questions on this? Do you understand the whole looking at the other fraction to help you figure out the factors? Sometimes kind of cheat the system, like, I don't know how to split up an 84. Well, a 12, an 8, or a 6. Do any of those help me? Well, 8 doesn't divide. 12 does, but it's 12 and 7, which that doesn't give me an 8. Maybe a 6? Oh, there it is. So kind of, you can use other factors in the problem just on the outside chance something cancels, you know. Not that it always has to. Homework for this evening. Homework for this evening. Maybe a little bit more practice with this. Page 48, numbers 35 and 37. Page 48, numbers 35 and 37. So just a couple division problems there. And then on page 55, do the review 1 to 13 odd. Page 55, the review 1 through 13 odd. We'll take a look at all of that in our next lesson as we look to wrap up fractions tomorrow. Have a wonderful rest of your day. When the bell rings, you'll be dismissed.